whether there are other sugars in breast milk that may be protective. So human breast milk is a very diverse mixture of bioactive nutrients, including sugars, mainly lactose. But there are also these other sugars called human milk oligosaccharides. These are complex sugars built of different units, as I'll show you in a moment. Fairly exclusive to humans. Humans in particular have over 100 oligosaccharides in breast milk. There's tremendous individual variation between women. And what's remarkably interesting about these oligosaccharides is that they are essentially prebiotics. They're not digested by the infant. They go straight to the colon, where they affect the microbiome, and in fact have been shown to have a significant role to play in things like immune development. So we've asked the question whether there's maternal transfer of sugars from the maternal diet to infant during breastfeeding, and we're looking at whether there are harmful effects or protective effects. And one of the first things we found, we did a study in collaboration with David Fields at University of Oklahoma. He had done this small study, I think there's about 30 women here, who we collected breast milk from at 1 month and 6 months of age, and he had measured infant body composition very accurately by DEXA. And we had a very simple question. The very simple question was, is there fructose detectable in breast milk? It wasn't something that anybody had ever looked at, and we certainly didn't expect to find it there, because from a natural perspective it shouldn't be there. But we did find significant levels of fructose in breast milk. You can see there's a variation across women from about 4 to 12, and those of you who have an astute eye will see that it's a very small concentration. We're talking about micrograms per ml. That's really small amount of fructose. But despite this low level of fructose, we see significant associations with infant body weight at 6 months, and all components, interestingly, of body composition, including lean mass, fat mass, and even bone mineral content. And no relationship with glucose, which is also detectable. So free glucose is also detectable in breast milk, but it was not significantly associated with infant body composition. So the next question we had was, well, how does it get there? How does fructose get there? So we had another very simple question. Simple question here was, is fructose transmitted from the maternal diet into breast milk? And we designed kind of a very simple, silly experiment. Again, in collaboration with David Fields, Oklahoma, recruited 40 normal weight women who were either normal weight or obese. And it was a very simple pharmacokinetic study. They were randomized in a crossover design to either drink 20 ounces of Coca-Cola or Diet Cola in random order. And what we did was we sampled breast milk every hour on the hour after consumption of those two beverages in a random crossover design. And we looked at breast milk concentrations of different sugars. Here's the glucose concentration at 0 hour, and every hour in blue is after the Coca-Cola, high sugar. This is a high fructose corn syrup beverage, so there's a high dose of free glucose and free fructose. You can see a small blip in glucose concentration after 2 to 3 hours, but it comes back down, and there's no difference to the Diet Coke treatment arm. Breast milk fructose, though, on the other hand, increased significantly. Again, we're talking about microgram per ml concentrations. Different group of women, but same level of basal concentration of about 6 micrograms per ml. Increases to about 10 micrograms per ml after 1 or 2 hours, and interestingly is sustained for up to 5 hours. This level at 5 hours is still significantly elevated. So here we do see significant transmission of fructose into breast milk that's transmitted that would be consumed by the infant. And then you're probably asking, so an infant gets microgram levels of fructose, does it have an effect? And I don't know the answer to that. We haven't done the experiment other than to show you that it is epidemiologically associated. But here's one possible mechanism where it might have a profound effect. This was an experiment done, published in 2012 by a group from UCLA. Going back to culture, these are pre-adipocytes, so these are early differentiating fat cells in culture. And they incubated these fat cells with different concentrations of fructose and looked at gene expression of different things. And I'm showing you here PPAR gamma and GLUT4. And I'm showing you these ones because these are known to be adipogenic, meaning they can promote adipogenesis, which means fat cell proliferation. And you can see for PPAR gamma, there is a significant effect, but you need 100 micrograms per ml. But look at this result here. This is remarkably interesting to me. At 10 micrograms per ml, which is about the concentration we see in breast milk, we see a massive increase in expression of GLUT4, which is not affected by dose. So it's almost like an on-off switch that is turning on expression of this gene. And we know from animal studies, if you take a mouse and you make it transgenic to overexpress GLUT4 in adipose tissue, it will improve glucose tolerance, but those transgenic mice will have a 2 to 3-fold increase in body fat because of fat cell hyperplasia. So very small levels of fructose, at least in culture, can turn this on, and if you have an animal that has exclusively this turned on, they will have adipocyte hyperplasia. So here's a possible mechanism. We have to connect the dots on this in humans, which will be very challenging, but at least it's a possible mechanism. Now, in the closing moments, I'll come back to the early study where I started. This was the data I already showed you, if you remember, at the very beginning of the study from the 1,500 Hispanic children consuming different amounts of sugars and the prevalence of obesity in those groups. Now, another element of this study that we found that was very interesting and got us interested in breastfeeding and breast milk was the data I showed you was in children who were either never breastfed or breastfed but for less than 12 months. Okay, it didn't matter if it was less than 6 months or less than 12 months. We combined the data, and this is how the group looked. There was no variation with less than 12 months breastfeeding. But when we looked at children who were breastfed for more than 12 months, now it didn't have to be exclusive. They just had to have some degree of breastfeeding for more than 12 months. Same experiment, same data, and here we see small improvement in obesity prevalence, small improvement here, but the most remarkable thing was this. In the high consumers, if the children were breastfeeding for more than 12 months, that extensive breastfeeding obliterated the adverse effects of high consumption of sugary beverages. So what is it about extended breastfeeding that is protecting these children? This is something that now we're very, very focused on. Now, I don't have the answer to that question yet, but we're funded to look at it. And what we're looking at are these oligosaccharides. These are the oligosaccharides I mentioned. These are just 4 examples of more than 100, but they're made of these building blocks of galactose, glucose, fucose, and acetylglucosamine, and acetylneuraminic acid that can be combined in different order. Think of them as like Lego blocks that can be put together in different combinations, or they could be branched. And as I mentioned, these are prebiotics that affect the gut microbiome, and we're interested in how they affect infant development. This was a study we did, our first study that was published. These are the 17 most abundant oligosaccharides that are measured by mass spectrometry by my collaborator Lars Bode at UCSD, who's one of the world's leading experts in oligosaccharide analysis. And you can see we don't really know very much about these compounds, how they change during lactation, how they're affected by maternal diet. We don't really know the answer to those questions yet. But in this particular preliminary study, you can see some of them go up during the first 6 months of breastfeeding, some of them stay the same, and some of them go down. But what we found was that some of them are associated in a protective way with infant body fat. This is 6-month infant body fat by DEXA, and these are 2 of these compounds where we found evidence of an inverse association where high levels of these oligosaccharides were associated with lower levels of infant body fat. So now we're trying to reproduce this in a much bigger study and ask the question of how this comes about. Is this because of the effect of these prebiotics on infant microbiome development? So this is where we are now. We're in the middle of this study of recruiting Hispanic women and their newborns, filling freezers full of milk and stool, separate freezers, and doing that every 6 months for several years and making outcomes of infant body fat. We're also looking at cognitive outcomes. Our first baby just turns 2 next month, which is when we can start making reasonable measures of cognitive outcomes, which we're also going to be looking at. So much more to come from this. I want to thank my collaborators, postdoctoral students who've been very involved with these studies. Scott Konofsky and Emily did the rat brain studies. David did some of the initial breastfeeding studies. And Lars, as I mentioned, doing the oligosaccharide analysis. My funding from DK and NIMHD, Gerber Foundation, and Atkins Foundation. You can find my papers on my website, and you can email me and ask me any question you want, and I'll try to answer them. Thank you very much again for the attention and for the invite. Thank you.